Hi everyone. In today's video, I'll be going over our study guide for the Unit 4.1 test. Number 1, find the arc length and area of the sector for each. So on the test, we're going to give you the formulas for these, but we're not going to specify which formula represents arc length and which one represents the area of a sector. So you will have to know which one is which. Arc length is deceiving. It starts with an S. S equals theta over 360, where theta is your angle, times 2 pi r, and area of a sector is A for area equals theta over 360 times pi r squared. So for these, to easily tell them apart, know that A always stands for area. It can be very tempting to look at this and think that S is area of a sector and A is arc length. But no, remember, area is always represented by a capital A. So if this is the area, then the S has to represent length, and it does. So we're going to practice just plugging our numbers in and getting an answer. So for our first problem, we have R equals 15 and theta equals 50. When you go to plug this in, make sure theta is in degrees. As you can see, it's over 360, so it does need to be in degrees. If it's in radians, like part B is in radians, we'll have to convert first, and then we can work with our formulas. So to find arc length, S equals 50 over 360 times 2 pi r is 15. And we just plug all that into a calculator. Area A equals 50 over 360 times pi, this time it's r squared, so 15 squared. Make sure you're careful. If you haven't noticed, the formulas are very similar to each other, so it's very easy to write down the wrong thing as you're looking over here. And then we just plug that into a calculator. And I've already done that. So when you plug those in, you get 13, and there's no directions for rounding. I'm pretty sure the test has it 3 places, so that's what I'm going to do on here. 13.0, and then this gets bumped up to 90 here because of the 9 after it. So you can write 13.09 or 13.090. Those would both be correct. Centimeters. And then the other one, the area, 98.17, the 4 gets bumped up to a 5 here. Centimeters squared for area. And that's all you do. Part B, same idea, only difference is this is given in radians, so we do have to figure out what that is in degrees before we can proceed. To convert between radians and degrees, we remember that 180 degrees is equal to pi radians. So we put what we want on top. We want degrees, so put 180 on top. I have radians. I want to get rid of it, so I'm going to put that on bottom. So when we multiply, the radians are going to cancel. The pi's are going to cancel, excuse me. And then we just multiply 7 times 180 divided by 10, and that's going to give you 126. So now theta equals 126 degrees. Now we just plug everything in. S equals 126 over 360 times 2 pi r is 9. And when I put that in the calculator, I will get 19.792. Area, 126 over 360 times pi r squared, 9 squared. That's going to give me 89.064. And the length label is just inches. The area label is inches squared. Lastly, C. This one's already given in degrees, so we don't have to do any extra work here. Just plug in our numbers and get our answers. S equals 150 over 360 times 2 pi r is 11. And that's going to give us 28.798. And for area, label, this is feet. For area, 150 over 360 times pi 11 squared. And that will give us 158.389. And that should be it. Next section, graph the given angle in standard position, then list two coterminal angles, one positive and one negative. So let's go ahead and graph it first so we get an idea of where this is at on the unit circle. So we have 5 pi over 8. So we're in radians. First off, our starting point here is always 0. Again, this is in radians. This is also the 2 pi mark. If we were to go completely around one time, we'd end up at 2 pi here. Meaning halfway over here we have 8 pi. Or sorry, just pi. But since we're in eighths, should have made more room here. This is 8 pi over 8, which is still just pi. So that's for this spot here. So we know that 5 pi over 8 is between 0 and pi, or 8 pi over 8. And it's slightly closer to 8 pi over 8, because our middle here would be 4 pi over 8. So we're going to draw 5 pi over 8 about here. And then we need to give coterminal angles, one positive, one negative. So a coterminal angle is an angle that's in the same spot as the one I have drawn. After I go around a full circle in the positive direction, and then when I go backwards in the negative direction, the same angles that are in the same spot as this one, but they're not 5 pi over 8, they are a different number. So we're going to do plus or minus, and then be careful here. So if we go in the forward direction, we are adding 2 pi, not pi. So 2 pi for the eighths is 16 over 8 pi, since 16 divided by 8 is 2. So we're going to do plus or minus 16 over 8 pi. So I'm going to add 16 over 8 pi, and I'm going to subtract the 16 over 8 pi, and I'm getting my two coterminal angles. So 5 pi over 8 plus 16 pi over 8. That's going to equal 21 pi over 8. And then if I do 5 pi over 8 minus 16 pi over 8, that's going to give me negative 11 pi over 8. So those are my two coterminal angles. Part B, theta equals 5 pi over 8. So same idea. I'm going to graph where that is on the circle. So this time we're in degrees. So we know that the starting point here is 0 degrees. We know that on the left side here, halfway around the circle is 180. And then if I do a full circle, this is 360. So 375 is obviously is past a full circle, but not by much. So we're going to be over here for 375 degrees. And technically, to be completely correct, we draw from the starting point here. So we started here. This would be like going around one whole time, and then another 15 degrees. And let me actually draw that for my other one too. I'm really bad about this. Okay. So coterminal angles. We're going to add a full circle, 360 to this, and we're going to subtract it. So plus or minus 360. 375 plus 360 is equal to 735 degrees. And then 375 minus 360 is equal to 15 degrees. So these are my positive and negative coterminal angles. C, theta equals pi over 5, so same idea. And I'm going to draw my graph over here just because of space. So again, 0 is on the right. Regular pi is on the left, 1 full pi. So in fifths, this would be 5 pi over 5. So pi over 5 obviously is between 0 and 5 pi over 5, and it's much closer to the 0. It's going to be over here somewhere. Something like that. So, again, we need to make sure in radians we're adding a full circle, which is 2 pi. So, 2 pi and fifths is 10 pi over 5, because that's 2 pi. So I'm going to take pi over 5, I'm going to add 10 pi over 5 to give me 11 pi over 5. And then I'm going to subtract 10 pi over 5 from pi over 5. Be like 1 minus 10, that's negative 9 pi over 5. And that's it. Those are my two coterminal angles. Next section, convert from radians to degrees. Pretty easy. So we're using the fact that 180 is equal to pi. So when we're going from radians to degrees, we have 7 pi over 12 times, when you're converting, you put what you want on top. We have radians, we want degrees. So we're going to times it by 180 over pi. The pi's cancel, so we just got to multiply this through. 180 times 7 1260. And that's going to be over 12. And this actually divides nicely. This is 105 degrees. So that's my answer in degrees. I'm going to repeat that for part B. 17 pi over 10 times, I'm going to do the same factor, 180 on top, pi on bottom, because I want degrees. These cancel. 17 times 180. This one does not divide very well. 3060 over 10. Oh wait, actually it does. Divide by 10, I'm going to knock off that 0. Going to be left with 360 degrees. 306 degrees. Big difference. Okay, not too bad. These don't come out as pretty. Number 4, convert from degrees to radians. So this time we're going to multiply by pi over 180. Because now I have degrees and I want radians. So we have 45 times, I have degrees, so I'm going to put 180 on bottom to get rid of it. Put the pi on top to create radians. So this becomes a 145 pi over 180. Now this does divide a little bit. We can divide both of these by a 5. 145 divided by 5 leaves us with 29 over 180 divided by 5 is 36. Clearly that is not going to simplify more. 29 is a prime number. So that unfortunately is our answer. Thank goodness we don't have to graph it. All right, theta equals 215. Same process. Multiply by pi over 180 to get radians. So it's going to be 215 pi over 180. Once again, we can divide by a 5 here. 215 divided by 5 is 43, which again is a prime number, so it's probably not going to come out nice. 36 on bottom. That's about all we can do. That's our answer. Number 5, find theta if we're given this information. Sine of theta equals 1/2 and tangent of theta is greater than or equal to 0. So what can we gauge from this? Sine of theta equals 1/2. First off, sine is a positive. Tangent is greater than or equal to 0. That means tangent's also positive. Something to remember, a bit of notes. We showed you guys how to remember which of the functions are positive in which quadrants. The point of this information initially is figure out which quadrant we are in, because obviously it's going to make a big difference on what theta's value is. So we want to find which quadrant. And remember, we showed you our acronym All students take calculus. A for all, so sine, cosine, tangent, positive in here. Students, S, sine only is positive. Take T, only tangent is positive in quadrant 3. C for calculus, C, cosine is the only positive here. So if we've got 2 of the 3 positive, we know we're in quadrant 1. Help if I had shown you that the whole time. My apologies. So we're in quadrant 1 here. Don't need to draw this super large just because all we're trying to figure out here is what theta's value is. So something else we can gauge from this. Let's go ahead and draw our triangle at least. So all we know about our triangle is in the first quadrant. That's it. So sine equals 1/2. Sine is also O over H. That means O, the opposite, which is always the Y, the vertical, is 1, and H is 2. If you remember your triangle ratios, which if you don't, you need to for the test, they are 30, 60, 90, which is 1, rad 3, 2, and 45, 45, 90, 1, 1, rad 2. So based on the information given in this triangle, we have a 1 and a 2. That should tell you we have a 30, 60, 90, so our third side is rad 3. And since 1 is across from that reference angle, that means this is 30 degrees. So that means our alpha value is 30 degrees. And looking at where we're at in the graph, that means this angle here is also 30 degrees. So theta is equal to 30 degrees. And then if they asked in radians, that would be pi over 6. Because reminder, you do have to have these memorized. Pi over 3 is the opposite of what you think, it's 60 degrees. Pi over 4 is 45 degrees. And pi over 6, again, the opposite of what you'd think, it is 30 degrees, not 60. So it's best if you have these memorized. If not, you could always just convert from one to the other. So something to remember. So the question was find theta. We have found it. It is 30 degrees. Now we're going to repeat that for part B. Part B, I'm going to warn you, is a bit tougher. You'll see why when we get through it. Cosine is equal to rad 2 over 2. That means it's positive. Sine is less than or equal to 0. Sine is negative. So we have where cosine is positive and sine is negative. So we want to know where cosine by itself is positive. That's in quadrant C, quadrant 4. So I draw my picture. I'm going to have it in quadrant 4. So we're in here. I'm going to draw this out. I have no idea what it is. Make that triangle, reference angle. Let's see what we can get from here. Cosine of theta equals rad 2 over 2. This is A over H. So that means that A equals rad 2 and H equals 2. So A is on the x-axis, that's rad 2. H equals 2. H is our hypotenuse. So now let's look at those ratios again. I'm going to take this away for a moment. We have two types, 30, 60, 90, 45, 45, 90. Now we have a hypotenuse of 2, which that would be a 30, 60, 90, but then we don't have a rad 2 in here. But we have rad 2 in the 45, 45, 90, but it's the hypotenuse in the ratio, and my hypotenuse is 2. So we have something fishy going on here. I will go and tell you one of those ratios is the one we need. Let's talk about which one in just a moment. Let's go ahead and find this missing side. If you can't use the ratios to find it, the thing you can always use if you remember from geometry is Pythagorean theorem. Pythagorean theorem is used for right triangles, and it's only used when you know 2 of the 3 sides and you're only missing one side. So let's use Pythagorean theorem to find this missing side. Hopefully remember a squared plus b squared equals c squared. C is the hypotenuse, so you have to make sure that C is in the right place. So A will be our rad 2 squared, and B will be unknown. Rad 2 squared is just 2, plus B squared equals 4. Subtract 2, we have B squared equals 2, and then square root both sides. B is equal to the square root of 2. So this side is also square root of 2. Now let's look again at these ratios. So we have rad 2, 2. I'll write those out. So if you plan to use this trick I'm going to show you, make sure you put the numbers in order first. Now, obviously, these don't quite match something we have over here, like exactly, but the pattern, the fact that the legs are the same, and that this, the legs are the same as each other, should be able to give away this is 45, 45, 90. 1, 1, rad 2. If you're unsure, which I am personally when I'm looking at this, you can get these numbers from what I have. Let's turn these into ones. And I don't actually want to get rid of the numbers per se. So I'm just going to kind of do this as like a checking step. But I don't want to actually change them. So to turn these into ones, they have to divide by rad 2. So let's divide all of these by rad 2. These both become 1. And then 2 over rad 2. As you know, we can't leave it like this. So let's change that. Let's rationalize the denominator. Times rad 2 over 2. This becomes 2 rad 2 over 2. 2's cancel. And we get rad 2. So we do end up with 1, 1 rad 2. So this is a 45, 45, 90. So this here is our 45-degree angle. So here, alpha is 45 degrees. Now to figure out where we are at, and if you haven't noticed, we're not told whether to do radians or degrees. So in my opinion, degrees is going to be a lot easier here. This right side here is 360 degrees. And we know that alpha is 45, so we just got to do 36 minus 45 to get this angle, which is 315 degrees. Now, we're not given, so if we did radians, 45 degrees is the same thing as pi over 4. So if this is 2 pi, this would be 8 pi over 4, this would be 7 pi over 4. Just an FYI if we did radians instead of degrees. But obviously degrees are easier. So this felt like a lot of weird work to get to our answer. Reminder, the numbers we were given didn't fully fit the ratios exactly, but you can see that the relationship is still the same as one of our special right triangles. So keep that in mind. Back page. Cosine of theta equals rad 2 over 2. Sine of theta is greater than or equal to 0. So we're actually working with the same exact triangle we just used, except it's going to be in a different quadrant. By the way, while it's on my mind, this is just going to bother me. I forgot to put the negative on that rad 2. Not that it made a difference on my answer. Just want to let you know. So I'm going to draw that same triangle, except here we know cosine is positive and sine is also positive. The only place where they are both positive is inside of that all space. So we're in quadrant 1 again. So I'm going to draw that same triangle I just had, except upright. So the side lengths are the same. So this is A over H. A is rad 2. A is on the x-axis. H is 2. And then if I did Pythagorean theorem again, I would get the same answer. So that's rad 2 as well. We already know this is 45, 45, 90. We have discovered that theta. Now this theta is going to be slightly different. Since this is in quadrant 1, we are 45 degrees for alpha. And then theta is also 45 degrees, which is also pi over 4. in case we were asked for radians instead of degrees. So those parts aren't that difficult. Now we just need to put together all the functions. So we need to find sine of theta. Cosine of theta is already given. It's rad 2 over 2. Tangent of theta. Tangent of theta, and then all of the reciprocals. So we have cosecant of theta. No. Yes, I said it correctly. I wrote it wrong. CSC. Secant, SCC of theta. Cotangent of theta. So, let me just label my letters here real quick. A is on the x-axis, O is the y, the vertical, and then 2 is our h. So for sine, we have O over h, which is rad 2 over 2. The same thing as cosine. Tangent is O over A. Rad 2 over rad 2, that's just 1. Continuing, we're going to find our reciprocals. Cosecant is just the flipped version, 2 over rad 2. If we rationalize the denominator, we are going to end up with just rad 2. I think we just did that here. Yeah. Oh wait, no, that was different. No, I should get the same. Yeah, I was thinking of something else. Sorry. So I've multiplied top and bottom by rad 2 over 2. There'll be 2 rad 2 over 2, which would cancel. Flipping rad 2 over 2, again, would get me just rad 2. And then cotangent of theta flipping 1 will still keep me at 1. So that is what we're supposed to get there. B, cosine of theta equals negative rad 3 over 2, where tangent is less than 0, so tangent is a negative. So here cosine and tangent are negative. There's only one place where they are both negative, and that is when the third function, sine, is positive. Sine is positive in the second quadrant. And before I continue, I meant to show you this. One good way to check your answers using this information. In part A, we got that all of them were in quadrant 1, so that means all the functions should be positive. So it's good to take a quick glance through here and make sure that sine, cosine, and tangent are positive as they should be. We're in quadrant 1. Same thing with their opposites. I'm going to use that in just a moment on part B for its quadrant. So since we have cosine and tangent negative, that's where sine is positive. So we are in quadrant 2 for part B. And I'm going to come over here for that just to give myself more space. So we're in quadrant 2. I'm going to draw out our triangle. So we know what cosine is. And this is A over H. So A is the rad 3 and H is 2. Now we have a negative in here. Remember, hypotenuse is always positive, so that means that the negative is going to go on the A. So we have H is positive 2, A is negative rad 3, which if you look at where it's at, it should be negative because it's on the left side of the x-axis, the negative numbers. So we have 2, and then we have rad 3 here. That does fit in with one of our ratios. Fits in with our 30, 60, 90, where we have a rad 3 and a 2. Our only remaining number is a 1. So, now we have the information for our triangle. We can find theta and alpha. Since this is 30, 60, 90, and we're across from 1, that means this angle is 30. So that means alpha is 30 degrees. And then theta, if this here is 180, and we have a 30-degree angle between the line I drew and the 180, that means this is 150 for theta. So now that we figured out those two, we can easily get our trig functions. So we have sine of theta. Cosine of theta was already given, negative rad 3 over 2. Tangent of theta. And then their opposites, cosecant, secant, cotangent. Sine O over H. O is always the vertical, A is the x, H across from the 90. O over H. O is, so it's going to be 1 over 2, 1/2. O over H. I'm going to go ahead and flip that to get 2 for cosecant. And then cosine, negative rad 3 over 2. Flip that. We have 2 over negative rad 3. If I rationalize the denominator here, I'm going to get negative 2 rad 3 over 3. And then tangent, O over A. We have 1 over negative rad 3. If I rationalize the denominator, that's negative rad 3 over 3. And then cotangent, I'm just going to flip this, flip the original. I'll end up with negative rad 3. And there are my answers. Again, quick check. We are in the second quadrant here, where sine is positive, cosine and tangent are negative. So we're going to check, is sine positive? Yes. Cosine and tangent need to be negative. Negative, negative, and then their opposites are negative as well. Just a quick check. 3 more. C. Sine of theta equals 1, cosine of theta equals 0. You need to be careful here. This is very easy to get confused on because these look different from the other ones. So I'm going to show you a few things to think about. First off, sine of theta equals 1. 1 is the same thing as 1 over 1. Cosine of theta equals 0, which is the same thing as 0 over 1. So if we take what we can from that, that means sine O over H. That means O equals 1, H equals 1, and that's in both of these. And then cosine, which is A over H, A equals 0. Now think about it before I go. Let me put a line through that 0, so that's 0, that's O. When we think about it, if we were to draw a triangle here, we couldn't have two sides be length 1 and one side be 0. So something should already be kind of going off like something's up, this is different. So let's go and draw our coordinate plane. So, reminder, A always goes on the x-axis. That's the x. There's nothing there because it's a 0. O always goes on the y-axis. So if we go up to 1 on the y-axis here, we would be at the point 0, 1. Now, this should make sense because if you remember from what we talked about on the unit circle, sine on the unit circle is the same thing as the y value, and cosine is the same as the x value. So we literally have the point 0, 1 here. And that's because this is a quadrantal. That means it's on one of the 4 parts of the axes. So that's why we didn't just have sine or cosine be negative or positive. Like we are given the specific values. So if we have a 1 or 0, any kind of combination of those on any of these 4 places, you have a special case on your hands. Now the math here is actually very easy to get our functions. And that's pretty much all I can graph here. I haven't drawn that arrow this whole time, by the way. I keep forgetting about it. Sine, cosecant. It's okay if you run into the space on D. You've got plenty of space to do D over here. Cosine and secant, tangent, and cotangent. All right, sine is O over H. We're given that, it's 1. If we flip that, that's still 1. Cosine is 0. Secant, when we flip 0, which is 0 over 1, we get 1 over 0. That's undefined. Tangent, that's O over A. O is 1, A is 0. That's undefined. And then cotangent is the flip of that, 0 over 1, which is just 0. So that kind of worked out. All right. Oh, I forgot to do alpha and theta. I knew I was forgetting something. So theta here, this is 90 degrees, also known as pi over 2. And then alpha is equidistant from both parts of the x-axis. It's 90 degrees away from both. So alpha here is also 90 degrees, also pi over 2, if we were able to put it in radians instead of degrees. Okay. D and E, these are back to kind of normalcy reality. These are the types of problems that we had quizzed you guys on. So hopefully those look more familiar than the ones I just did. Some of the ones I just did were a little uncomfy, but with practice, you'll get better at those for sure. Theta equals 135 degrees. So if we think about it, 0 is on the right, 180 is on the left. 135 is in between these two, closer to 180 for sure. And we know 90 is in the middle. So we know it's for sure in quadrant 3. Drop down our perpendicular. All right, let's see. We need to find our alpha. So we know theta is 135. Alpha is the distance from our theta to the closest x-axis, which will be going this way. 135 to 180, that is 45 degrees. So we now know we have a 45, 45, 90 triangle. That means the legs are 1, 1, and our hypotenuse is rad 2. Don't forget to come back to the legs. Are we supposed to have any negative legs? Yes. Here on the bottom, this is on the negative side of the x-axis, so this is the negative one. If I start at the x-axis and go up and draw the y part, the vertical part, I'm going up. So this is a positive one, as it should be. Now I can start putting things together. Also, as I go, I should remember that I'm in quadrant 2, which means I'm in the S part of that trick we showed. So that means that sine should be positive here when I find my trig functions, and that cosine and tangent should be negative. So you need to keep an eye out for that. So I have sine of theta, cosine of theta, tangent of theta, opposites, cosecant, secant, cotangent. And for good measure, let me label. H hypotenuse is across from the 90. A is on the x-axis, O is on the y. All right, O over H. That's 1 over rad 2. If I rationalize this denominator, I end up with rad 2 over 2. If I find cosecant and flip the original fraction, I'm just left with rad 2. Cosine A over H. That's negative 1 over rad 2. Very close to what the sine is, just negative. So I'm going to write negative rad 2 over 2. Cosine, secant, we're going to flip cosine. So we're left with negative rad 2. Tangent O over A, that's 1 over negative 1. So negative 1. And if I flip that, I'm still going to have negative 1. And those are my functions. Oh, before I leave, let's check. Make sure sine positive, the rest negative. Positive and positive, good. Cosine is negative as well as its opposite. Tangent is negative as well as its opposite. Now I'm going to move on. Last problem. Theta equals 4 pi over 3. Again, just graph it. Reminder, if you start in radians, you end in radians. So we are not going to be doing any converting for these problems here. 4 pi over 3, we're working in thirds. So we start at 0, radians, not degrees, I almost wrote that. If we go around halfway, we're at just pi, which since we're in thirds, this is 3 pi over 3. And then if I made it all the way back around again, this is 2 pi, which is 6 pi over 3 in this problem. 4 pi over 3 is obviously in between 3 pi and 6 pi over 3. It's a tad closer to 3 pi over 3. So I'm going to draw it here. Remember the line this time. Finish the triangle. Always come up and meet the x-axis. Let's see. We know that our theta is 4 pi over 3. That's given. Now let's find our alpha to see what type of triangle this is. This angle here, we are pi over 3 distance here. Distance from 3 pi over 3 to 4 pi over 3 is just pi over 3. Now, we should know that pi over 3 is the same thing as 60 degrees because they're opposites. So we do know we have a 30, 60, 90 triangle. And our reference angle here is across from 60, so across from that is rad 3. 1 goes on the other leg, and 2 goes on the hypotenuse. Before we forget, let's look at our sides. We're supposed to have any negatives. This side here that's vertical is a negative. If I start on the x-axis and go to draw it, I have to move downward to do so. So this is a negative number. X-axis is on the left, horizontal is on the left side of the x-axis, which is negative. So that's also going to be a negative. Thinking about our signs here, we are in the third quadrant. All students take calculus. The T for take is tangent. So when we do our calculations, T needs to be positive. So you need to remember that. I'm going to write that down to hopefully remind me to do that before I'm done. So we just need to find our trig functions: sine, cosine, tangent, and their opposites: cosecant, secant, cotangent. Sine is over h. It would help if I labeled my sides. A is always the x on the horizontal. O is always on the vertical with y. H is always the hypotenuse across from 90. Continuing, sine is O over h. So that's negative rad 3 over 2. Nothing to change here. Cosecant is flipped of that. Negative 2 over rad 3. If I rationalize that denominator, I end up with negative 2 rad 3 over 3. Cosine A over h, that's just negative 1/2. Flipping it, I get negative 2. Tangent over A, that's a negative rad 3 over negative 1, which is just rad 3. Cotangent is flipped of the original. That's 1 over rad 3. If I rationalize the denominator, I'm left with rad 3 over 3. One more check for good measure. Go back, look at which quadrant you're in. We're in quadrant 3, where all students take T, calculus, T for take, T for tangent. Tangent should be positive. Let's check. Yep, and yep. The others, sine and cosine, should all be negative. Negative, 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 negative. It's a good quick check to do before you wrap up. All right, that is all the problems on the study guide. Overall, I think that the study guide is pretty easy and straightforward, especially the front page. I definitely think that number 5, especially part B, and then A through C on the back are a bit more challenging. Even compared to some of the problems we've done in class, I felt that those were a bit challenging. These are even more challenging in my opinion. So make sure you know what you're looking for here. Take your time with these. If you have any additional questions, feel free to reach out to me either in person or via email. Otherwise, I hope you have an awesome day. Bye.